We are back for the second video, and we are starting at problem 6 of exam 2 prep. Right, so this says combining functions advanced. And so it says suppose that the functions f and g are defined as follows. We have f of x is equal to x plus 5, a nice linear equation, and then g of x is equal to the square root of 5x plus 4. Now this first part is actually going to be kind of straightforward, because if I take x plus 5 and I subtract g of x, right, which is just going to be the square root. It doesn't allow me to type in square root. I got to click. Oh, actually, I don't want that either. Where's the square root symbol? Here we go. 5x plus 4. There's actually nothing else here for me to do. This is it, right? There's no like terms for me to combine. I got x plus 5. I got minus the square root. Nothing else for me to do. The real tricky part here is the domain of f minus g. So we're going to jump over to our whiteboard here and see if I can find it. Give me 1 second. Okay, so I've written down on my whiteboard here. Let's go ahead and do this. Again, so for the domain, we're looking at, what are we allowed to plug in here? Now, I'm just going to go piece by piece. If I look at the x plus 5, I have no issues with this, right? I can plug whatever I want into this x value, right? Anything that I want. The issue arises here with this square root, right? Remember, I have the rule of no negative square roots. Right? And so what I'm going to do here is I'm first going to figure out when 5x plus 4 is equal to 0. I can have the square root of 0. Right, so this is what I'm going to be interested in, and then I'm going to avoid the negatives. So if I move over the 4 and I divide by 5, I have x is equal to negative 4/5. And again, I'm allowed to have the square root of 0. Right, I'm allowed to have the square root of 0. And so what ends up happening is, maybe some of you might already see where our brackets and our parentheses go. It might be a question, right? Some of you may go, it's negative 4/5 to infinity, right? Which this would be our correct answer, right? We start at negative 4/5 and we go to infinity. However, if there's ever any question, right? Maybe some of you thought, well, what about this answer? This kind of looks good as well. Negative infinity to negative 4/5. Right, well, if there's ever any question, right, you have your negative 4/5, which is where 0 is, and now you could just go plug in points, right? So I could see that if I plugged in a value over here, let's say a number less than negative 4/5, let's say negative 1, we'd end up with a negative value over here, and we know we can't have any negative square roots. And so I know that I need to be over here, right? So negative 4/5 all the way to positive infinity. Right, so that is our domain. Let me go back so we can type that answer in. Hopefully we can go back. Okay, let's go ahead and type this in, the domain. And the good news is negative 4/5, comma, let's get our infinity. Infinity always have a parenthesis. And same thing here for f times g, right? Let's just write out what this looks like. This is x plus 5 times the square root of 5x plus 4. And again, at this point, there's nothing really left here to do. There's no simplifying. We don't need to distribute out the x plus 5. That's not really going to be helpful to us. And also for the domain, again, we're kind of looking at this as what are we allowed to plug in for x? Well, the x plus 5, there's no issues there with the x plus 5, but we do have the same issues that arrive with this square root of 5x plus 4. And so we're going to end up with the same domain as above. To positive infinity. And again, always parentheses. Go ahead and check it. Looks like we're correct. Let's go ahead and move on to our next problem. Okay, next problem, number 7. Similar style problem, except before we had the subtraction or addition and the multiplication. Here we're going to have what's called composition. Right now, we are going to need to do a little bit of side work, so take a second, write down the functions. And then we're going to go through both the composition and the domain at the same time. Okay, so I have this written down on my whiteboard. Right, remember f of, right, this little circle here is the composition, right, operator. And so we're going to write f of g of x and so let's just go ahead and do this. Remember this x here, right, in our original f, it's just a placeholder. So now we're going to replace our x with a g of x. Or in other words, we have 5 over g of x plus 2. And of course, we know what g of x is equal to. So 5 over g of x is 1 over x minus 2 plus 2. And so I'm going to pause at this point because in order to do the composition and the domain, we kind of have to stop along the way to get the domain here. We'll notice, right, let's pay attention to, we have an x minus 2 in this denominator of our denominator. And so we end up with the issue of, well, we know that x can't be equal to 2. So let's just write ourselves a note. Right, x can't be equal to 2 here because if I put it in 2 for this x, I have 1 divided by 0, and that's going to cause a whole bunch of issues. Right, so we know that's the case. Let's go ahead and keep moving forward now with our composition. We just want to take a side note so that when we get to the domain, we have this already written out. Now, in our denominator, in order to combine these two things, right, I need to have a common denominator in my denominator. And so what I'm going to do is I have my 1 over x minus 2. And I notice that my 2 over here, you can think of this as a 2 over 1. And so I'm going to create a common denominator by multiplying the top and the bottom by an x minus 2 for this 2. Right, really fancy way of multiplying by a 1. And so now by doing this, I've created a common denominator. And so I have 5 divided by, this is 1 plus 2 times x minus 2 all over x minus 2. And we should go about simplifying this parentheses, right? Let's go ahead and simplify and combine like terms. First we needed to distribute out everything. So this gives us 1 plus 2x minus 4 all over x minus 2. So one more thing to simplify. So we have 5 over big, and we'll put 2x minus 3 over x minus 2. Okay. So far we're making progress. Still looks kind of ugly. I'm going to keep scrolling down. Now, you could imagine up here that this 5 is kind of like a 5 over a 1, if that's helpful. Essentially what's going to happen is this x minus 2 is going to make its way up to our numerator. Right? If we don't immediately see that, another way of thinking about this is this. I don't know if this will be more helpful or less helpful. Right? This is grouped together. So if I want to get rid of an x minus 2 down here, right, I would multiply by x minus 2. But if I do it to the bottom, I also must do it to the top. Right? Again, another fancy way of multiplying by 1. These would cancel out. And so I'm left with 5 times x minus 2 all over 2x minus 3. And again, last thing is just to simplify this out, right, 5x minus 10. And so there's a couple of things to note. Right, the first thing is you can type in your answer, this is our composition right here. Right, f of g of x, let's write this out. F of g of x is equal to 5x minus 10 divided by 2x minus 3. That is our composition. And we also said along the way, well, let's just write this in first. Let's go ahead, we'll write this into our solution. Right, well, I guess we won't go back and forth, we'll leave it. This is our solution to the first part. The second part asks about the domain. Now remember, from above, we can even see it really right here too. Right, we can't divide by a 0, right? I think we pointed it out a little bit up here, right? We can't divide by a 0, so x cannot be equal to 2. We'll just take a note. right? We said x cannot be equal to 2. And from our composition, our end process here, we can also see, again, we don't want to divide by 0. So 2x minus 3, we should set that equal to 0 as well and figure out when this denominator is going to be equal to 0. Right? So if we take our new denominator and set it equal to 0, right, this is going to tell us where we also do not want to be. So we have 2x equals 3, or x equals 3 over 2. Right? Again, we do not want to be these two values. Right? These two values will make us divide by 0. And so when we write out our domain, we're going to avoid these values. Right, so how do we avoid these values? Well, we start at negative infinity. We go all the way until we run into an issue, which is the 3 over 2. We skip over the 3 over 2. We go all the way until we run into another issue, which is a positive 2. And we skip over that positive 2. And then finally, no more issues, and we're done. So here's our domain. I'm going to pull over the solution in a second so you can see it in case you want to see both in the same slide. But we have to pay attention for composition to domain issues that occur along the way. Okay, so here was the final solution. Here's our composition. And again, here is our domain of f of g. Okay, we're going to keep it moving to number 8. Okay, it says finding the maximum or minimum of a quadratic function. There's a few different variations, so let's go ahead and do this. It says, here's your g of x, and says, does the function have a minimum or a maximum value? Now, I'm going to go write this out on my whiteboard, but this first part, anytime we have a positive x squared for a quadratic, we are going to be looking at a minimum. This is an upward-facing parabola, and I'll make a quick sketch of this. Right, so minimum. If it's negative, this is it'd be a downward-facing, and we'd have a maximum. Okay, so I have the function written out. Again, this looks something like this, right? So it makes sense that we're looking at something that has a minimum, right? This would be the least value here. Now it does say, let's see, actually we should have read the rest of the question, huh? Let's go back and forth here. Let's pull this up. It says, what is the function's minimum or maximum value? And then it says, where does it occur? So this is the y value, and this is the x value. Now, it's kind of in reverse order the way that we really got to go about the problem. We need to find the x value first, actually. Right, now if we look at this, our minimum value, there's another name for this. This is known as the vertex. And so we know to find the x value of the vertex, it is negative b over 2a. In this case, right, the b is referring to our middle coefficient, so negative 10, all over 2, and a here is referring to this first coefficient, which is a 1. And so we end up with negative 5. And so this tells us the x value where the minimum is occurring. Right? It does not tell us the y value, but the good news is when we started this whole problem, I gave you a relationship between x's and y's, and so now we can go utilize that by plugging in the negative 5. We have negative 5 squared plus 10 times negative 5 plus 26, in which case we're going to get 25 minus 50 plus 26 ends up being a very nice number, or in other words, a positive 1. Right, so here's our maximum, our minimum value, and this is where it occurs at, right? Let's go ahead, we'll jump back. So we have 1 was the minimum, and it occurred at negative 5. All right, let's try another one. Oh, not this one though. We want a different one. Give me 1 second, and we'll pull up the next variation. It's very similar though, right? So same idea. It says a ball is thrown vertically upward at t seconds. Its height h in feet is given by the function h of t is equal to 88t minus 16t squared. What is the maximum height? Or in other words, when it's saying maximum and minimum for us talking about quadratics, which is what this is, it is really just asking us another form of a vertex question, right? It says, what is the maximum height the ball will reach? And so the height, notice here, where's my cursor? Right, remember this is telling you the height in time. Now, before we can really go find the height, I need to find the time that this is occurring at. Or in other words, I need to go find the x value, or in this case, the t value of the vertex. So let's go ahead. We have 88t minus 16t squared. And so we're back to the usual of let's go find the vertex. Well, in this case, our t value, again, negative b over 2a. Oh, there's a t here, by the way. Now just be careful. I'm going to rewrite this so it's in the correct kind of format that's helpful for us. And so in our case, our negative b here is negative 88. And then this is 2 divided by, or 2 times negative 16. So let's see. It doesn't look like this is going to be a nice value, does it? We have 88 divided by 32, in which case we're going to have some sort of time value. 60, what do we got here? Sorry, I'm going to go back to old school thinking here. 64, 24 over 32. And I'm just going to simplify it because I'm guessing it wants time, not as a fraction. What does this simplify down to? 3 over 4. So this is 2.75, right? As our time value here. Now I'm going to cheat a little bit. I'm going to tell you what the next step is. I don't have a calculator in front of me. You're just going to take your 2.75 and plug it in, right, to your initial equation. And this is going to output the height for you. And at this point, we would refer to a calculator. I don't expect anyone to do this. Just decimal multiplication in their head. Probably might not be too bad, but let's go ahead and see. We'll push solve, right, in which you would have got 121 feet. Okay, so let's go. We're going to keep moving to the next question. Okay, last one involving maximum areas using a quadratic. This is an optimizing area using a quadratic function. Right, we did one of these similar in class. It says a wire that is 16 centimeters long is shown below. The wire is cut into 2 pieces, and each piece is bent and formed into the shape of a square. Suppose that the side length in centimeters of one square is x as shown below. And it says find a function that gives the total area a of x enclosed by the 2 squares in square centimeters in terms of x. Okay, so now the first thing we need to know, or first thing that we need to realize, is that this information here is giving us a relationship. And so we're going to go form this relationship before we move forward into A. Okay, I'm going to go write this down on my whiteboard here. Okay, so that's my rough drawing. Now, what it's given us, it's telling us that the perimeters of these squares, and I'm just going to name this one y for right now, that the perimeters of these squares, these are all x's, squares all have the same side length, right? Or in other words, 4x plus 4y should be equal to 16. Right? This should be equal to 16. It's saying that if I go all the way around this square, which is 4x, and I add all the way around this square, which is 4y, it should add up to be the sum of the total wire that they give you, which is 16. And so we're just going to hold on to this relationship for right now. We're going to use it in a second. Now, it says in our problem, it wants, for part A, it says find the area. And now it does say according to x, we're going to kind of not pay attention to that fact right now. But if I was looking at square 1 here, right, well, that's obvious. The area of a square would just be the side squared, right, x squared. However, the area of my second one is y squared. Now, again, this wants us to write the area in terms of x. Now, the good news is this does develop a relationship here, right? When we wrote this down, this gives me a way of writing y in terms of x, right? So 4y is equal to 16 minus 4x, or in other words, y is equal to 4 minus x. And guess what? Now we can go rewrite our equation, and instead of writing y squared, we have 4 minus x squared. Now it does want us to simplify, so let's go ahead and simplify everything. We have x squared plus, let's say, 16 let's make sure, oh, you know what, did I mess up? No, I think we're good. Minus 4x divided by 4. That looks fine. So we have 16 minus 8x plus x squared. And so if we simplify down, we have 2x squared minus 8x plus 16. Give me one